Welcome to qnawire.
In this problem, we want to look at, we again have an ideal Rankine cycle. And this time we're going to look at the effect of the condenser pressure. Okay, and we're going to go from 5 kilopascals to 100 kilopascals. And again, I plotted various things out here, and this should be kilojoules. These are in kilopascals. Okay, the high pressure we kept, the boiler pressure was at 10 megapascals here. Efficiencies in that work. So we can basically see that efficiencies go down as the condenser pressure goes up. So we want to get this pressure as low as possible. But again, you got to worry about leaks and stuff. Although, basically, if you get it down to almost zero, you don't really have a very big pressure differential between the atmosphere and zero pressure. So leaking is probably not really a problem. It's just, trying to, get it, just keep the low pressure is, basically leaking in, air leaking in is probably more the problem there. Oh, okay, and then net work actually goes down. I looked at the quality factor coming out of the turbine, and that stays, for all this range, stays under 1. And then again, all of these guys, and we can see here that the work under the pump barely changes, and again doesn't change things much from here to here. But some, because we're at lower things here. So let's see here. We'll make some plot. And so here's the cycle. This was 5, and this I guess this was always at 10 megapascals. So 5 kilopascals in this case. Down here at the very extreme. You can see here that net work continues to go down, efficiency continues to drop, and quality factor continues to rise as we get as we increase the pressure at the condenser. So there's not a lot to say about it. But we get you can see over here, we go down here from up here we have about 1,000 or 1 megajoule per kilogram, around these ranges. Up here where I converted this to kilojoules here. So we're at same kind of range here. So we can actually get you can kind of effectively change things quite a bit with the condenser pressure, even though we're only changing it over a range of 100 kilopascals. This changes quite a bit for that. And again, the efficiency, we can get it up. So, and again, the quality factor basically changes because we're essentially moving this line up, right? And so we move this line up high enough, and then we'll get outside of this zone here, and this will continue to go up. I think that's pretty much everything there is to say about that case.